This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Episode of Design Safe Radio. I'm your host, Dan Zahner, and if you couldn't tell by the background today, we are talking about coastal engineering with Dr. Nina Stark, who I'm really excited to see. We've been colleagues for, sheesh, it's been 9 years now.
Yeah, more, I think, yeah.
I think you've aged a bit better than me. I've got a lot more gray around, but it's great to have you from the University of Florida. Tell us a little bit about yourself, and then we'll get going in with some questions about your really amazing research.
Sure, I'm an associate professor in the Department of Civil and Coastal Engineering at the University of Florida. And my research is really in between the fields of geotechnical engineering and coastal science and engineering. So I'm interested in coastal processes, but I look at them from a geotechnical perspective. So I'm interested in soil mechanics and how sediment moves and why it moves and how it responds to stresses and loads. And I do that in underwater environments, sometimes rivers, but mostly at the coast and in not too deep in water depths. And in that regard, we are also encountering quite a bit of hurricanes, other storms, and floods. And so naturally, this topic of natural hazards is playing quite a significant role in my research. Other than that, my research also includes quite a bit of fundamental work with regard to trying to understand the connections between erosion and geomechanical properties, as well as we are contributing quite a bit to different civil engineering applications, as well as naval applications, such as unexploded ordnance site management or trafficability.
Wow. Yeah. You're one of those people who are like the epitome of a NEER researcher. You've got a lot of different disciplines going on, a lot of different varied expertise. I mean, I keep looking at the schedule and seeing your name pop up and all sorts of interesting collaborations. So it's always fun to hear what you're up to.
Yeah, absolutely. I think that also comes with the field. So I'm truly convinced that these problems cannot be solved with one perspective in one discipline. So naturally, we are involved in a lot of multidisciplinary projects. And, sometimes we don't even know yet what kind of disciplines we really need to solve these problems, right? So that's, I think, how even if we are maybe right now not working with a certain discipline, that doesn't mean in 5 years we may not be working with them anymore. We start working with them. And so I think that is really a very intriguing part, in particular of the type of research we are doing. So I work with a lot of different people who have very different perspectives on the problems. And the really cool thing is that we are all working together to really joint goals of improving safety and resilience of coastal communities from natural hazards, as well as I mentioned, solving other engineering problems in civil engineering with regard to infrastructure, as well as other applications.
Yeah, and one of those collaborative efforts that you're part of, we've talked about, I think the last time we had somebody from one of the extreme events research groups, probably Tracy Kajewski-Correa, way back. But these are formal National Science Foundation supported groups that are dedicated to collecting this perishable data. Can you tell us a little bit about you're in, I think, 2 of them, the Nearshore and Geotechnical, which we'll refer to NEER and GEER from here on out. Give us a little bit about those guys, and we'll dive, no pun intended, into that a bit.
Sure. Yeah, sure. Let me maybe start with GEER. So as far as I know, GEER is actually is probably the first of what we often refer to as the EARs, the Extreme Event Reconnaissance Association. So GEER exists, I don't want to bet on it, but I think since the 90s, and started actually focus on earthquakes. And so geotechnical engineers from practice, academia, and federal agencies came together and built this group that practically comes together when extreme events happen to collect data that will improve our understanding of the mechanisms, what is happening during these extreme events, and then how does it come to these impacts, and what can we do about them in the future and improve it. and have done so since then and have really expanded in different extreme events that they have tackled, as well as in membership. I don't have the exact numbers, but I think GEER has actually quite substantial member base of geotechnical engineers from, again, academia, practice, and federal agencies, and the different perspectives, again, become really important here for these events. And then later on, and again, I don't have the exact times, but so different years started to form, focusing on other topics. And NEER, so the Nearshore Extreme Event Reconnaissance Association that I'm also affiliated with, is kind of unique in that whole world as well, since they are not so much focused on a discipline group, but on an environment. So the idea is really to be focused on the coastal zone and the nearshore zone, but bringing in people from a wide range of disciplines to actually look at these impacts. And so these associations, by actually having that network already, I think a key thing, in my opinion, is since the network exists, it's so much faster in communication amongst all these experts to actually get going, get on the road when these events happen, to make a plan and get out there and get this data. And you mentioned perishable data before, so that's really important. So I think something that would otherwise be really difficult is, so if you're thinking about a typical research effort or even just an engineering project, right? So they're typically being planned. There's a long planning phase, and then they go into actual action of data collection or construction. But so there's quite some time, right? And with these extreme events, we often don't really have, or we typically don't have that planning phase because we don't really know, right? I mean, we don't know when they occur and where. Maybe we have an idea of, obviously, of vulnerability of certain places to certain extreme events, as well as maybe a timing if we are thinking about hurricane season or so, right? We have kind of an idea of where and when, but until actually something becomes a little bit clearer, we don't have really the option for detailed planning there, right? So it's all at very short notice. And even then, earthquakes are even more extreme case for that, right? So you are fully reactive. But staying with the storms, for example, you can plan to some degree, but not fully. And so these groups, by having the network, practically enable a quicker communication. And the perishable data is important, since not only these events are occurring kind of unplanned, but we obviously have to prioritize the health and the well-being of the communities, right? So we cannot say we have to keep the status quo after an extreme event just so that we can collect data whenever we are ready to collect data. But we have to collect the data pretty much parallel to cleanup work, to repair work that are really essential. But also there's not natural processes that will actually change possible observations, right? So it is important to really get there and collect this data immediately after these events, and if possible, sometimes even during these events, so that we actually really get a comprehensive data set. And that is really this perishable data, right? The perishable data that is being lost if you cannot get there and collect that data at a certain time.
Yeah, it's because these communities, whether it's a hurricane or an earthquake or a landslide, they're wanting to get back to normal life and clean up
absolutely.
debris and move sediment off of roads and clean up spiders and all sorts of other fun stuff. Washed on shore, or remember back in, this was a long time ago, Hurricane Harvey. You just get all sorts of stuff pushed around, and they're just trying to clear roads. So the research community wants to know, fundamentally, how are things like bridges and signs and billboards and hotels and all the things that make up our world, how do those react? And your spot there in the nearshore is really interesting, because as you mentioned, it's not focused just on the wind side, it's not focused just on the waves, but it's the environment. How do you collect some of this data? Because it's such a wide variety of disciplines working together. What kind of instruments do you use for that? What kind of data are you collecting?
Yeah, so I typically think in four big pillars that are kind of overlapping. So one is really topographic or bathymetric data. So thinking about processes like erosion, right? So how does actually the geomorphology change? Where are we losing land? Where are we maybe gaining land because the sediment that was eroded in one place is ending up there? We had, after Hurricane Irma, a really great example where we had one house that was pretty much destroyed by scour and erosion, and the other house was destroyed by deposition because all the sand actually ended up there. So
Wow.
understanding, so understanding actually how the sediments are moving, getting eroded and deposited somewhere else, and it's not only traditional erosion; it may also be mechanisms like slope failures and others. It is a really important part. So that means actually measuring the topography. And if you're in the coastal zone, that means not only on land, but ideally also in the water, because otherwise you're always missing a part of the puzzle, right? So it's important to do both. Gives a good idea of, okay, where did we actually lose land? And that may actually impact infrastructure, right? Like scour, if we are eroding sediments, right, at infrastructure systems, we are possibly weakening their foundations and so on. So being able to monitor that and understanding why did that happen in that spot and not in the other spot is really important. So topographic data, bathymetric data is one really important component. Another one, what are the forces really driving it, right? What is really bringing in the energy? So looking at your background here, right? Waves, storm surge, but also currents, right? If you're thinking about a storm surge pushing on land, it's squeezing between these houses, right? And or it may even like go under roads, right? And going through the soil, creating some internal erosion, or creating little tunnels and scouring out things again, right? So actually understanding what are the driving forces is really important. So water levels, so traditionally that would be often like that and we still are doing that, looking for high water marks, right? At houses or infrastructure where we see how far did the mud get up there and things like that. But nowadays we have new sensors that are, or not, they're not that new, but I think it's getting newer that we are deploying them throughout these extreme events and that they're more rugged. So actually measuring what are the waves here right on this spot, right? And what was the storm surge right here are really important measurements to understand what was really the driving force. Going back to this example of scour at some infrastructure, for example. So now I measured how much material was eroded, and now I measure practically what was the water flow, and so the forcing that eroded this material. And then as a geotechnical engineer, there's obviously another really big component, and that is actually the sediment and soil conditions, right? So it makes a huge difference if you're on a tidal mudflat, or if you're at a sandy beach, if your house is built on sand or more on other materials and fill. So actually collecting sediment samples, doing in situ, so in place testing of strength of the earth materials are another really important component. And then going back to this multidisciplinary theme, we have sometimes colleagues from field of ecology or biology who come out and for example, evaluate like performance of oyster reefs, right? So, or mangroves.
Yeah.
That's something that I cannot really evaluate. But so there's this fourth pillar of a lot of other data that could be collected in other places that may be more related to even chemical aspects, right? Like pollutants also that may have come in.
Oh, wow. Yeah, that makes sense. As you were talking about the different places where houses are built, right? That old song I used to sing as a kid in church, like the wise man built his house upon the rock. Foolish man built his house upon the sand, and now on the sand went flat. Yeah. Anyway.
Yeah.
Sorry for all of your ears out there. I mean, this is so cool that the variety of research. I mean, from chemicals and how they flow to looking at before and after bathymetry, all the offshore topography. Gosh, I remember a rapid workshop 2017 or 2018 or something. We were playing around with the Z boat, that's autonomous boat that has sonar on it. You guys get to play with some really cool instruments.
Oh yeah, we play with really fun tools. Yeah.
How did you get involved in this?
Um, well, I think so. When I was an assistant professor, there was an opportunity GEER mobilized for a flood event in Christchurch, New Zealand, that occurred fairly shortly after that earthquake series. And the goal was to understand, what are the combination pretty much of first these earthquakes and how did this flood then practically come on top of the previous earthquake damages and impact practically the community there. And so that was actually my first interaction with GEER, and I learned a lot. It was a fantastic team, and I got really excited about the concept of GEER and just this opportunity of measuring shortly after these events with this group of experts with these different perspectives and angles on this topic. And my research has always been kind of focused on trying to measure geotechnical properties in energetic subaquatic environments. So with the energetic, I think that is already the nudge towards these extreme events. And for my whole career, I've always enjoyed, I guess, this problem of if someone says, oh, it would be great to have this data, but we don't know how to get this data. That is something that excites me, because then I want to either take sensors that are already out there and practically modify them or misuse them for something that they're not being built for, or develop our own sensors to actually get this data that is needed. And in particular in this field, there seems to be quite a bit of that, and opportunities to be not only creative in the fundamental research of the processes, but also the research on how do we actually measure these things, right? How can we... And it is an interesting field because you have to balance trade-offs, right? So, I mean, there's always this dream instrument, but then you also have to work in this challenging environment, right? So if you have the most sensitive sensor, that may be great, but it may also get really beaten up, right? And then you don't have data. So you have to do these trade-offs.
And I just spent $100,000 on an instrument.
Exactly. And I truly enjoy that. And I think that's something is how I got slipped more into that. And then when Harvey came along, I was a member of GEER, and I showed interest in the one thing that we brought up, myself as well as some colleagues were like, hey, should we try to get pretty much right into that back of that hurricane? And that is additionally challenging, right? Because people are still like reacting to the hurricane, right? And there's first responders, and in utmost importance is that you're not in the way of first responders, that you're not making life harder for the communities there, right? So it makes the research a little bit more difficult because there's more variables you have to consider. But at the same time, thinking again about this perishable data, I thought was really important, right? And so what we did for Harvey, we were a small team of 5 out of a bigger team that made the whole GEER team for Harvey, but we went practically behind Harvey, right behind it, and tried to collect this super fresh data. And that was a great data set that actually brought a few first things on the way. We did something similar for Irma. And then now for Helene, we actually really embrace this idea of pre-storm, during storm, post-storm collection. So going back to your question, how did I get into this? I think I'm intrigued by measuring these things that are hard to measure and that we have as a community struggled to measure and try it. And sometimes it doesn't work, and then we try again, right? And so, but that is really what drives, I think, me specifically. Plus, obviously, the bigger picture motivation that I feel that we can really make a change there if we are understanding the processes better.
Yeah, exactly. And I'm glad you set me up with a really great segue into talking about the 2024 hurricane season. What were those deployments like? How was it like working with the team last year? And can you tell us about some of the data you gathered and things that you learned?
Yeah, so Helene was kind of special in that regard that so I remember on the Saturday before, so Helene made landfall on a Thursday, and the Saturday before people were still kind of like, maybe it's coming, maybe it's not, and maybe it's big, maybe it's not. On Sunday, it became a little bit more clear, and we actually started talking with NEER about possibly mobilizing. And so on Monday, we had a first more formal meeting with NEER leadership and possible participants, if it would make sense to mobilize for this. And one key point that came out for us, why this actually became a big deployment or made a contribution, why it became a big deployment, was that at that time, it seemed to be more likely that Hurricane Helene would actually impact a zone of the Florida West Coast that is, first of all, close to UF, and secondly, is an area that we had actually collected data over the last 2 years for other research purposes, for other research projects. So we kind of knew the sites. We had maybe an idea of more vulnerable spots, as well as kind of different environmental conditions that we would be interested in. So at that point, with hurricanes, you have an approximately idea where it's going, but you don't really know exactly where it's going. So if you want to deploy before the storm, you're always running in the risk that you are still in the wrong spot, right?
Right.
However, in that case, we made the decision based on that colleagues who are more involved in actually the prediction of the hurricanes, they said, well, you may not be right in the center spot, but that area will very likely be impacted. And we felt that was good enough to make a first attempt to actually getting sensors in front of the hurricane, and then we can at least demonstrate how this could work. And since this was also kind of close to UF, that allowed us to have a home base, right, that is not too far away, and then we can practically retrieve to fairly easily, because you also don't want to be, during the hurricane, another person in the way of this hurricane and make possibly trouble for, again, first responders or people who try to keep the community safe, right? So we decided to go for this area of Cedar Key to Horseshoe Beach, that at that time on the Tuesday did not even look to be kind of in the main area of the hurricane impact, but close enough that it would probably feel something. And so we had actually technical staff members from the NEER Rapid facility come over with equipment. We had our Center for Coastal Solutions staff get out with instruments. And so on Tuesday, people were flying in. On Wednesday was pretty much all hands on deck. We had multiple teams in the field deploying sensors at different places, as well as practically collecting pre-data. And for example, another really big achievement was my colleague Brian Phillips and his team were able to put a Sentinel tower also in Cedar Key, so out at the beach, right there. And so on Wednesday, everyone was out there. We were collecting this data, and the goal was on Wednesday evening, practically, let's go back to Gainesville, let's be out of the way. And some of the team members that flew in even kept traveling practically home to be completely out of the zone. So that made this deployment kind of unique. And to be honest, at that time, we didn't really know where this would be going. But then on Thursday, Helene took a twist to the right, and actually we were right in, not at the landfall spot, but practically on the right-hand side of the landfall, so in an area that experienced really high storm surge and had a lot of really devastating impacts. So we had 21 wave gauges deployed, and we got them all back. Shockingly, there was sometimes infrastructure and built environment items behind these that were completely destroyed or even gone.
Whoa.
And so that created like a really unique data set, as shocking as that was. And it is, as a researcher, I will say emotionally, it's quite hard, because while I'm happy that my wave gauge is recovered and has data, I feel terrible for the people who own the property that and just lost a lot, or in some cases everything, right? So it is quite challenging there. So then on a couple of days later, we recovered the sensors, because the impact was so severe we really wanted to make sure to give it a couple of days. We communicated with first responders in the area and police to make sure, again, that we can get in and we're not in anyone's way. And so we covered the sensors, we got everything back, we got an amazing data set, but we also collected an initial observations of the impacts, and they were just devastating, right? It was really shocking. And I mean, I do want to point out that that was also just like a small part of Helene. We all know that Helene just went up and created more and more disaster practically across multiple East Coast states, right? So we were just focused here on a small portion in Florida, and that was already really, really bad. And it did, with the data we had already collected, it made it, however, clear to us that it would make sense now to continue and collect more data, this really, really detailed data set to, as terrible as these events are, but as a silver lining to at least get the most data out of it and learn from it, and hopefully then improve community resilience in the future, right, and just protection mechanisms. So then, based on that, it works like that. Or what we did, we tried to identify what are the data products we need. We talked a little bit earlier about the typical data products we're looking for, and then practically finding people and experts who can provide this data, who are really ideally the top people who are available to come out and assist. But we also try to bring in new young folks, right? Because we are trying to build up also a community of people who can do this. Because honestly, as much as I do enjoy doing my research, these hurricanes are really hard emotionally as well as in work. And so we need more people who do what we are doing to collect this data, right? So we had a great team. We had up to, I think, more than 35 people in the field at a time.
Oh, wow.
And we had people from the whole country, from different institutions, federal agencies, from industry joining us again. We had different teams in different places trying to organize, making sure that we don't overrun certain property owners. Because we had really, I want to point that out, a fantastic support from the community, despite them just having experienced such a, truly extreme event. Right. They were very supportive, allowed us access. A lot of our sensors and measurements were actually on private property, and people actually allowed us the access and responded, and it was all thanks to the community really there. And so we had a larger data collection effort planned, and then Milton came along, right? And targeted area again, hit a little bit further south. So we had to shift actually our data collection slightly to make sure we are not bringing more people into Florida or right into the area where Milton was projected to go. And we then, as soon as Milton had passed, we focused on the Cedar Key area to follow up on the Helene data collection. And then we actually sent a sub-team a little bit south to actually explore some of the impacts from Milton, and in particular, the 2 Barrier Island breaches that occurred. And so that led to another phase of data collection. Wow. Since we saw that, so we didn't really have the time to do that in that one sequence, but then we had team members come in again in November to collect data at those breaches. So it was a pretty intense fall, yes. In particular, if you think about, again, like going back to this idea that you cannot really plan for this like we usually plan for our projects.
Right. Well, and over the past, decade that you've been working on this, you've gathered expertise and experts and have kind of a playbook put together for certain things. But even with that, every event is different. So yes. How are you, as we're inviting in new researchers, young faculty, early career professionals, to maybe set up a new home base at their institution, LSU, or wanting to get involved in these intense, time-sensitive, really fun outdoor work, what advice would you have for people wanting to get into this?
Yeah, so I think be proactive, right? Join NEER, join GEER, join STEER, whatever is your your closest to home discipline, right, or topic. I think the ears, they also communicate amongst each other, but I think joining these communities, seeing the chatter, right, the messages when there's mobilization, getting reports, seeing what others did, right? I think that is a really good first step. And then also being proactive about contacting people, right? Letting people know, hey, I would be really interested in collaborating with you, or if you just have the chance, if I would have the chance to join on one of these of mobilizations, or some, maybe it's not even a mobilization yet, maybe it's more helping remotely, right? I mean, it's there's a lot of people involved, and not everyone is just in the field, right? There's also people who are practically assisting us with information that can be a good first step. And to be honest, another really important one, I think that people are not really thinking about enough yet is, I mean, we are collecting this data. At least I see it, and I think most of us see it that way. We are collecting data for the research community. And so we're uploading the data and making it available through Design Safe, right? So the data is already there. So if someone really wants to get involved, I think one thing that is also a really great opportunity, look at the reports, look also at the data sets that are available. And how do these data sets actually match your research interest? This data is public. The Helene data is, for example, already public. Typically, all these teams try to publish the data very swiftly so that people can use it. Using the data, getting involved, showing interest in it, and then maybe starting collaborating, maybe with some team members or maybe with new people. I think that is also a really great opportunity to get involved that some people don't really think about yet, because if you have already worked on some of these event data before, you probably have a more informed ability to contribute to a future team, right? So I think,
Yes.
I think that, so if you're just thinking about an approach, if you're saying, hey, I just want to participate, sure, that's an option. But if you say something like, hey, I actually worked on Hurricane Harvey data that was published there, and I noticed this and that, and I thought it would be really great if we would also have this data, and I would like to contribute, that's also, and maybe even a more intriguing approach to get involved.
Yeah, and like you said, I mean, all that data is already up there. It's free, publicly available. You know, you don't have to be a PhD to access it.
Nope.
You can be an undergrad and be just, I
Yeah.
heard about this really interesting concept in my class today. I wonder if there's any data I could apply that to. You know,
That's
all
right.
sorts of things
And we
like that.
And we have had undergrads joining us and helping in the field as well. And again, I encourage everyone to be proactive, reaching out. Typically, people like me, we are not annoyed about people reaching out. We are excited if people show interest.
Yeah, absolutely. And so to that end, how can people follow along with your research, get in touch with you, maybe before hurricane season, which you got like 2 weeks if this goes live before then, or come to the Summer Institute if you're going to be there? How can folks get in touch and follow along with what you're up to?
Sure. I mean, if people see me at conferences, always swing by and say hi. You know, I'm always happy to meet new people and chat with people about what they are doing.
And you always have good recommendations for where to find good coffee.
That's right. That's right. Exactly. And obviously, just email me. It's nina.stark@ufl.edu. We also have a website that you can look at some of our other projects. Yeah, just reach out either via email, check out the website, or just start talking to me at a conference if you see me there or any other place. So it's pretty easy, and I'm actually pretty good with responding.
Excellent. Well, really appreciate your time, Nina. Thanks so much for that, and good luck in this upcoming hurricane season. And like you, hoping that you're just sipping Mai Tais on the beach or playing with your horses rather than going to deploy. But we know you're going to be ready if that happens. So thanks so much, and keep up the great work.
Thanks so much, Dan. Thanks for having me.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay